Last video we talked about rule 2, okay, and the Ralph-Hurwitz, which is the magnitude criterion. And then now we talk about rule 1, which is the angle criterion. Okay, so angle criterion wise is similar to what rule 2 has said. Okay, it's just in terms of angle now. Okay, and then this rule 2, as you can see, is whatever distance from your s value, your chosen s values, to wherever your poles and zeros where it is. Right, it's all the distance to open loop poles or distance to open loop zeros, that's all. So nonetheless, the angle criterion is whatever angles to the poles and whatever angles to the zeros where you want to see. Okay, so maybe so this is the standard rule. I recommend you memorize all the criterion because the test will actually ask you what are the criterions. Okay, so you have to write down leading to the angle criterion, angle, whatever, you have to memorize this. So angle subtended from zeros minus angle subtended from poles equals to has to be equals to minus 180 degrees plus minus. This K is different from the controller K, which should be Q, 360 degrees. Nonetheless, I'll just show you the example so you can get a feel of what actually the whole angle criterion is all about. Okay, so let me take a look. Typically, if you are talking about only typically this rule 1 is only applicable for the imaginary axis, which all this imaginary poles I would say not imaginary. So for everything that happens on the real axis, okay, this is not much applicable because let's say the angles from zeros. Let's say if you pick a point, let's say I pick this point. The angle from zeros, because since this is 0, the angle from 0 to 0, any 0, because there's only one zeros ma, so angle from zeros is always the same, so is 6 is 0 by itself, and then minus the sum of all, this is sum of all angles from zeros, and this is the sum of all angles from poles, right? So therefore the from the poles itself, as you can see, it is 180 degrees. It is minus 180 degrees towards the 0. Okay, we should be using this one. Okay, I just realized anyway. So 180 towards, okay, this is the angle from, this is the point where you want to look at it. Okay, the zeros from zeros is 0, and then sorry, the point where the angle from poles is over here. The angle from poles to this point is minus 180 degrees, and the angle from this poles to this point is also minus 180 degrees. And then similarly, the angle from this pole to this point is also, to this point, okay, to this point is also 180 degrees. So therefore, if you were to sum it out, it's minus 540, and then here we have plus 540 degrees. As you can see, you have plus 180 degrees plus some 360 degrees, which in this case, Q is equals to 1. Okay, and then in this case, negative, perhaps you should put it as minus 4 and then minus 180 degrees plus, type of thing. So this is a little tricky. I can't talk much about this because it's quite abstract, because I can go anywhere. But the general concept is this. So let's take a look into if you have imaginary, so that you'll be much clearer. So sorry. So imagine if we have a transfer function. Okay, let me hold on. Let's say you have a transfer function of maybe how do I say it? K, and then s squared plus 6s plus 10. Okay, and then s plus 2, s plus 1. Okay, so this is a transfer function, open loop transfer function. And then this portion here, if you were to expand it, you will become this form over here. Okay, there's a trick to this. Okay, there's a trick to this thing. So make sure I hope I can help you understand. Is that if you encounter this thing and you're trying to if you okay, let's say if you encounter this thing and trying to form it into such complex number, okay, the way the way we do is actually to have a minus s in front, okay, because as you can see, typically if you were to do a quadratic system, you may have some values, right? So in this case, it's minus 3 plus I, and you have minus 3 minus I, right? Minus 3 plus I, and minus 3 minus I over here. If you were to solve for it, end up you will have minus 3s minus is, right? And then minus 3s minus is. So end up you have minus. Okay, hold on a moment. Maybe I should show you an example. Okay, that will be clearer. Typically, if you saw this, right, s squared plus 6s plus 10, you would be tempted to actually write s plus, and then the rest of the imaginary number. And then it is also quite tough to see, right, whether is it how do you derive from here imaginary or not, or how do you deal with these things, right? It's kind of typically you will use quadratic equation for to solve. If you want to solve until here, you can actually use this equation, and then you use the quadratic equation b squared minus 4ac. But if you want to try to determine here to here, and then you're trying to see anyway, never mind. I just want to let you know that if you happen that you have s squared plus 6s plus 10, make sure whatever in front is negative. That's all. Okay, and then the rest you figure out yourself. It's a little tricky. Okay, so make sure you know that you should, if you're talking about this minus, okay, never mind. Just perhaps let's say if you are given these two poles and you're asked to derive the the poles of the equation, okay, because now this is imaginary poles, right? So the poles of equation should be this one, right? One equation. So you're asked to derive that pole. So how do you do it? Typically, you take this pole, one of the positive pole you put over here, and then another pole you put over here, and then minus s plus, and then the rest is minus s. So you just need to remember that. That's all. Okay. So I repeat again. If you are asked, I don't think you ask, but if let's say you are unlucky, so let's say you have these two poles over here, okay, typically you know that they share the same equation, which is a quadratic equation. And what you're gonna do is actually take this pole and then you put it in the complex place, and then you use this one and then you put it in the complex place also. Then you use minus s and minus s instead of s, because if you use s plus this one and then you multiply, okay, end up you have a minus 6s over here, which is the wrong answer, and no one will gonna verify it for you, right? So therefore, what I'm gonna do is actually to recommend you, if you were to happen that you encounter this type of problem, put a minus in front. That will solve the problem. Okay, if you are dealing with this type of equation, root locus, because as you can see, this is minus, right? This is more minus. So this minus sign actually may hinder your, if you put plus s, it may actually cause the whole thing to become, minus 6s, right? So the reason why I put minus over here is actually when you multiply into here, you get positive 3s, and then you can add up together. So this is the general concept I want to convey, but nonetheless, this is totally unrelated to our angle criterion. So let's continue first. So let's say if you want to find the angle criterion from pole is equals to minus 1. So it should be about this point over here, right? So as you can see from the angle criterion is the angle from the zeros, right? As you can see there's no zeros, so we can actually say that there is no zero. Minus away the angle from all the summation of all poles, okay, from all poles and all zeros. So this is all poles. So all angles from poles. So let's start off with here. So the angle from this point to this point, what is the angle? The angle is this angle, right? And how can you find the angle? Okay, this height is actually j, right? This is j, and then there is a distance of minus 2, right? So what I can do is that, since you know the rule, the trigo rule, this is 1, this is 2, and you want to find the angle, okay, what you're gonna do is actually use the tangent inverse 1 over 2. Okay, if you do that, as you can see, it's 26.56. Okay, but however, since your angle is over here, this is definitely 26.56, right? As shown over here, it's tangent 1 over 2, right? Opposite over adjacent. Okay, so therefore, since you're over here, the positive side, it's you have to add in. So this is 90 degrees. Okay? Hold on, I confused myself. Okay, it is actually an angle downwards. You are talking about angle from the poles, from this pole to here. So the angle itself is actually negative 26.56, right? So therefore, as you can see, I should be writing here at 26.56. Okay, and then okay, let me replace this first. Actually, I have a lot of calculation error over here. Shit. So therefore, this is the angle from this pole to this -1. Okay, so you're trying to find all poles subtended from wherever you are. Okay, and then the next pole is actually from this pole to this pole, right? As if you don't know why, it's because we're trying to find all angles that is towards this pole. This angle to this pole, this angle to this pole, um, this angle to this pole. Okay, so we are trying to find this angle also. As you can see, I just do this first. So this is one angle towards this pole, which is actually negative 180 degrees. And then there's an angle over here. By far, it should be what would this be? Hold on a while. Okay, so this should be, because you're taking an angle from this pole to this pole, so it should be this angle. So it should be 9. Since this is 26.56, so 90 minus 26.56, it should be some values of 64 degrees. Okay, negative 64 degrees. Okay, it's going in this direction, right? It's going to this. So it's negative. If you were to add out, okay, so this is a wrong shape. You add out, you have minus 270.56. Okay, so minus 270.56, and this is actually not the angle. Okay, so this is not the angle yet. Okay, you have to plus another 180 degrees. Okay, this is the rule, right? This is if you are taking the distance from the poles. Okay, you are taking 180 degrees, and then you minus away. This is actually the phi angle. Our phi angle is taking all the angles, okay, from all the poles and zeros, and then you're trying to locate the point over here through angles. Okay, so you're taking this angle and taking this angle and taking this angle. You are giving a angle defined point. Okay, so let me repeat again. You're defining this point with angles. Okay, this angle, and then this angle, and this angle. From here, you can straight away know that the point lies with across this angle, because how you determine this angle? Yeah, determine using um the trigo rule, right? The j is equals to 1, right? And then you have a distance of about 2 2. Okay, if so, you are taking tangent um minus 2 and minus 1, minus half lah, I would say. So from here you can actually know how the distance would be. So the angle describes this this distance just by the angle itself. So the angle will straight away point to here. So the intersecting point will be somewhere around here, somewhat lah. So the angle criterion is actually to use angles to help us understand. But when you find this point, you're actually finding the angle over here only. You still have to add 180 degrees. So if you were to do that, you have about 90. Is it 90 degrees? Yeah, hold on a while. So so it's 90 degrees. Okay, minus 90 degrees. And then you may ask me what is the meaning minus 90 degrees. Okay, so it's a distance from. Okay, hold on a while. Yeah, I'm not much sure what is this angle means. Okay, maybe meaning that the summation of all the angles from zeros and angles from poles, you can define an angle that is based on all these points. As you can see, they are all heading back to a certain point. They are trying to describe this point. So all these angles add up together will give you the overall point from somewhere. I have to figure it out. So maybe I'll do the next. I'll do videos on it if I find out. But nonetheless, you can actually go. I'll recommend you to watch Hisu Roka's video on angle criterion. Later I'll just post it after this video. You can just watch it. But nonetheless, if you are given any question, you find all the angles towards whatever point you want. Almost any point, unless you are specified, then you have to find all angles from this point, and then after which then you can determine how. Okay, what, and then you can find the values. Okay, this when you minus all this, when you add up these things. Okay, these are all the poles, right? Because we have 3 poles over here, right? So sorry, we have 3 poles lah. This is 1 pole, this is 1 pole, and this is 1 pole. So if you add up, you have is minus 270. It should be minus minus, so it should be plus over here, right? So and then nonetheless you'll get 90 degrees here and there. I don't know how it works, but you need to make sure you plus 180 degrees for some reason. I also don't know why. That's why I say you should go and watch this video. I'll just show you. But nonetheless, how do I say it? This is also related to also the one of the rule in bottom, angles of departure and arrival. I'll just talk about it briefly. So the angle of departure and arrival is simply saying, remember all the poles will go to the zeros, right? So all the poles, so this is the poles, always the poles will go to the zeros. So if the poles is, as you know, poles will always go to zero. So this is wherever poles to some point is always angle of departure, because you're going to some place. You're always going to departure. So angle subtended from poles is actually called departure, angle of departure. Okay, so I repeat again, any angle subtended. Okay, subtended means that let's say you have this point over here, you want to find this point, right? You have to find this point, and then any angle subtended from the pole, this angle subtended from this pole is this angle over here, right? So this angle over here is actually the angle of departure. While let's say your zeros is over here, right? And the poles will definitely go to zeros, right? So the angle from subtended from any places. This angle is angle of arrival, because all poles are arriving towards the zeros. So any angles from the zeros, okay, let's say angles from zeros is always talking about angle of arrival, and then any angles from the poles is actually angle of departure. This is the notes you need to take now. And then also this one, any values that you found over here, let's say we found negative 270 plus 270, you have to add plus minus 180 degrees. I don't know how we want to plus it, but maybe in the tutorial about that I'll just show you. So I'll just end this video on rule 2 and rule 6. Okay, mostly on the angles part. I believe this video sucks, but hopefully it gives you some intuition, and that actually the transfer function that I showed you earlier, okay, is actually this going in this direction. Yeah. So just to show you lah, okay. Yes. Yeah. So I'll see you in the next video to talk about the special case of rule 5 and 8. So this is more on the tricky side lah. So I'll see you in the next video.